Welcome back, dear denizens. This is your Science Hub, Top 10 Den. Today we're traversing into an enigma-packed landscape as we delve into one of the most fascinating scientific domains, physics. Prepare yourselves for a mind-expanding trip as we unveil the top 10 unsolved mysteries in physics. At number 10, we're starting our journey with the elusive dark matter. Despite contributing approximately 85% of the universe's total mass, dark matter doesn't interact with light or other forms of electromagnetic radiation, making it tremendously tricky to detect. Scientists are aware of its existence due to the observable gravitational effects it has on galaxies. Dark matter is like that silent roommate who never says a word, but his presence can be sensed when he moves around the furniture. The mystery lies in what exactly dark matter is composed of. Current theories suggest it could be made up of new yet undiscovered particles. Researchers worldwide are conducting experiments to detect these particles, but their elusive nature keeps them hidden in the shadows of the unknown. Will we ever shine a light on this dark mystery? Only time will tell. Gravity makes its appearance at number 9. This fundamental force might be responsible for keeping our feet on the ground and planets in their orbits, but its true nature is still a cosmic conundrum. Einstein's theory of general relativity offers an elegant explanation of gravity, yet it is incompatible with quantum mechanics, the other significant pillar of modern physics. This incompatibility presents a puzzle. Quantum mechanics is incredibly successful in describing the very small, the realm of particles, while general relativity brilliantly describes the very large, the realm of stars and galaxies. However, when you try to apply quantum mechanics to gravity, the maths simply falls apart, like trying to fit a square peg into a round hole. It's like trying to blend oil and water. At number 8, we have neutrinos, the universe's most famous wallflowers. These tiny subatomic particles are constantly whizzing through the universe, barely interacting with anything. Right now, as you're watching this video, millions of neutrinos from the sun are passing through your body, and you wouldn't even notice. Neutrinos are a head-scratcher for scientists because of their light mass and their ability to switch between 3 different flavors. While scientists have made strides in detecting and studying these elusive particles, there's still a lot we don't know about them. For instance, we still don't understand why neutrinos have mass, which contradicts the original standard model of particle physics. It's like finding out that ghosts can have weight. Landing at number 7, we have the ultimate origin story, the Big Bang. According to our current understanding, this colossal explosion gave birth to our universe around 13.8 billion years ago. But what about the time before that? It's like our universe's biography begins from Chapter 2, but Chapter 1 is nowhere to be found. The problem is that our laws of physics break down when we rewind the clock to the moment of the Big Bang. Our current understanding can't answer what there was before it, or even if before makes sense in this context. We're still waiting for a breakthrough that could provide us with a better understanding of this cosmic prequel. The Matter-Antimatter asymmetry problem claims the number 6 spot. According to our understanding, the Big Bang should have created equal amounts of matter and antimatter. However, when matter and antimatter meet, they annihilate each other. So if there were equal amounts, we shouldn't be here. But here we are, which means there is more matter than antimatter in the universe. So what led to this imbalance? Is it possible that some process resulted in a surplus of matter particles over antimatter particles? This profound asymmetry between matter and antimatter remains one of the biggest unsolved mysteries in physics. It's like the universe played favoritism, and we're on the winning team. The mystery of time earns its spot at number 5. Time, as we understand it, moves forward, never backward. This is a fundamental aspect of our experience. But why does time have a direction? Why can't we unspill a cup of coffee or unbreak a vase? While the laws of physics work equally well if time flows forward or backward, our everyday experiences only move in one direction, from the past through the present into the future. This conundrum, known as the arrow of time, is deeply linked to the nature of entropy and the second law of thermodynamics. But why time has an arrow remains an open question. It's like time has a one-way ticket, and we're all just passengers. The number 4 slot goes to the weird world of quantum entanglement. This strange phenomenon occurs when particles become interconnected, and the state of one can instantly affect the other, regardless of the distance separating them. It's like having a twin who feels your pain when you stub your toe, but your twin is on Mars. Quantum entanglement defies our intuitive understanding of the world, and was even troubling for Albert Einstein, who referred to it as spooky action at a distance. Although this effect has been demonstrated in laboratories, how it fits in with the rest of physics remains a conundrum. Is there a hidden variable we haven't discovered yet, or do we have to accept that the quantum world is fundamentally spooky? At number 3, we're tackling dark energy. This mysterious entity is thought to make up about 70% of the energy in the universe and is responsible for its accelerating expansion. Imagine driving a car that starts to speed up the moment you take your foot off the pedal. That's kind of what the universe is doing. However, what exactly dark energy is, where it comes from, and why it's causing an accelerated expansion of the universe is still a mystery. Despite significant observational evidence for its existence, it's remained resistant to direct detection or measurement. For physicists, dark energy is like a riddle wrapped in a mystery inside an enigma. Our number 2 spot is claimed by the enigma of consciousness. How does the brain, a 3-pound mass of wet biological matter, give rise to self-awareness, emotions, and thoughts we all experience? The transition from physical matter to subjective experience is a substantial jump, and it's one that science is still trying to understand. While consciousness is more often a topic for philosophers, understanding the physical and biological processes that result in consciousness is a significant challenge for neuroscience and physics alike. It's like trying to figure out how the characters in a movie could come out of a simple DVD disc. Finally, taking the coveted number 1 spot is the holy grail of physics, the theory of everything. This theory is supposed to unify all fundamental forces of nature, providing a single framework that bridges the gap between the quantum mechanics of small particles and the general relativity of vast galaxies. It's like having a master key that can unlock every single door in the universe. However, despite decades of research, this unifying theory has remained elusive. One of the main challenges is reconciling gravity, described by general relativity, with the other 3 fundamental forces: the electromagnetic force, the strong nuclear force, and the weak nuclear force, which are described by quantum mechanics. These 2 frameworks seem fundamentally incompatible in extreme scenarios, like the conditions in a black hole or the Big Bang. It's like trying to read a map where the north and south are drawn by different artists in entirely different styles. And there we have it, denizens, the top 10 unsolved mysteries in physics. Each of these questions demonstrates the sheer vastness of the unknown and the infinite capacity of the universe to amaze and baffle us. But the quest for answers is what drives scientific progress, and that's what makes it so thrilling. If you enjoyed this roller coaster ride through some of the most profound mysteries of physics, give this video a big thumbs up. We'd love to know which unsolved mystery intrigues you the most. Share your thoughts and theories in the comments below. If you haven't subscribed to our Top 10 Den family yet, don't hesitate to hit that subscribe button. We're on a never-ending journey to uncover the most fascinating insights from various fields of knowledge, and we'd love for you to join us. Remember, curiosity is the engine of achievement. Until our next adventure, stay curious, denizens.